Okay, so this lesson is going to be the Chapter 5 review. And remember, I'm going to do it just like I do in class. And what I do on the review is going to be the same kind of problems that you'll see on the Chapter 5 test that is this week. Okay, number 1 says to simplify 16t to the 10th over 18t to the 11th. So when we're doing this, remember the number part, remember we always have our calculator that can do the number part of the reducing for us, because that's what we're doing. We're reducing this fraction. So you'll just type in the number part, which is 16 over 18. Oh, turn it on. So 16 over 18, and then remember, if you want to make this into a fraction, you'll do math, go to math, and then hit enter, enter, and that reduces your fraction for you. So you can see that that 16 over 18 will reduce to 8/9. Now we need to do the t part. So I have t to the 10th up top and t to the 11th in the bottom. So if I wrote that all the way out, t to the 10th would cancel out t to the 10th down here, which means I'm going to have a t left over, but it's going to be in the bottom. So once this is completely simplified, all that I have left up top is that 8. And in the bottom, I'm left with 9t. And remember, you can pause me anytime you need. If you need it to go slower. Number 2, again, simplify. This time you have 5a minus 10 over 5. Now, unlike the last one, when I'm simplifying this one, I have 2 terms up top. The first thing I need to do is if there is any factoring to be completed, it has to be completed before you can do any of that canceling. So let's see, up top, what do you see that'll go into 5 and 10? Let's see, 5 will go into both of those numbers. And then you put in parentheses what is left. And remember how to find out what is left? You're going to divide both of those by that 5 that you just pulled out. So if I took the 5 out of this first term, all I'm left with is that a minus 10 divided by 5 gives me 2. So now I have a minus 2 in parentheses. All I have left in the bottom, I just bring over that 5. So now, looking here, you've got the 5 over the 5 that cancels. So all you're left with is a minus 2. Right, number 3, same thing, simplify. I've got 5z minus 35 over 5z plus 35. Now, just like that last problem, the first thing, just look at the top and the bottom separately because we're going to factor first. Up here, what goes into 5 and 35? Well, that 5 will, so I can pull out a 5. So if I pull the 5 out of this top, let's see, if I take the 5 out of there and take the 5 out of there, let's see what's left. Those 5s will cancel, so I'll just have that z minus 35 divided by 5 gives me 7. Now do the same thing in the bottom. Again, 5 will go into both of those, so pull out a 5. Once I pull out the 5 from both of these in the bottom, let's see what's left. Here, these 5s cancel, so I'm just left with that z plus 35 over 5 gives me 7. So once you have everything in factored form, then you can go through and do your canceling. Well, this 5 will cancel that one. So all you're left with in the top is the z minus 7. And in the bottom, you are left with z plus 7. So z minus 7 over z plus 7 is your answer. All right, number 4. Another simplify, s squared minus 9 over s squared minus 6s plus 9. So let's see, again, before we can do any canceling, we've got to factor everywhere that we can. So looking at the top, I have s squared minus 9. Now remember, before we left, that week before spring break, where we were doing all those different kinds of factoring in chapter 4, the factoring that we had that had 2 terms, but there wasn't anything in common that we could pull out, like on our last problems where the 5 was in common and we could pull it out. This one has 2 terms that are both perfect squares. So if that is the case with the minus in the middle, remember, it'll have 2 factors. Here, let's put it below. So this up top will have 2 factors. To get s squared, I need s and s. The same number that you multiply together to get 9 would be 3 and 3. And your signs were different, 1 plus and 1 minus. Then factor in the bottom. So I've got 3 terms in the denominator. Nothing's in common. 3 terms, and it's just s squared. So remember, that was the good kind of factoring trinomial. If it's just s squared, we know it's going to be s and s. Now, to help not make sign mistakes, remember, this is the number right here that you can put in your y equals. So if you're in y equals, clear it out. And let's see, positive 9 is what I want to put in. So on the top one, I'm going to put 9 divided by x. And in the second y, I'm going to put 9 divided by x plus x. So it should look like that. Now, once I do that, then I'm going to hit the second button and then the table button up here in the top right. Now, what I'm looking for in that second y column is this middle number right here, this -6. So when you're looking for the -6 in that second y, I see it down there at the very bottom. So see that -6 in the second y? That tells me that I need to use the 2 numbers, the x and the y1 as my numbers for my factors. So I'm going to use that -3 minus 3. Now, once I get the bottom factored, the s minus 3s will cancel. So what you're left with in the top is s plus 3, and in the bottom, s minus 3. All right, number 5 is a multiply and simplify. I've got x to the 7th over 7x plus 21 times 9x plus 27 over 9x to the 9th. So now remember, I want to go to every single spot and do any factoring that I can first. Then once I do that, then I will actually do the multiplying. So the first thing I'm going to do is rewrite this in factored form, because it looks like I can pull out a greatest common factor out of that one. It also looks like I can pull a greatest common factor out from up there. So let's see. I can't do anything with x to the 7th, so I'll just bring it down. Here, since 7 goes into both of these, I can pull out a 7. And then I'll put in parentheses what is left. Well, if I take the 7 out of both of these, if I take the 7 out of this term, all I'm left with is the x plus, if you divide this by 7, what do you get? You get 3. So x plus 3 in parentheses. Bring down the times. Now, up here, remember, we're pulling out the biggest number that goes into both of those, not just any number, but the biggest number. So the biggest number that goes into 9 and 27 will be 9. And again, if I divide both of those, I'll have x plus 3. I'll put that over, I'll just bring down that 9x to the 9th. Now, once I do that, I notice that I have x plus 3 in the top and the bottom. So let's go ahead and cancel those. And let's multiply what is left just to turn this into one fraction that we can reduce. So on the top, I have x to the 7th times 9, which is just 9x to the 7th. In the bottom, I have a 7 here times 9x to the 9th. So 7 times 9 gives me 63, and then x to the 9th. Now I can reduce this fraction. Remember, here's a part where you can do the math inner. 9 over 63 reduces to 1/7. It's a 7 down there. You can't see it. Now let's see, x to the 7th over x to the 9th. If I do that canceling, x to the 7th here, we'll take out x to the 7th down there. So I still have x squared in the bottom down there. So I still have 7x squared in the denominator. So let's see, what is left? My 7x squared is what's left, but it's in the denominator, which means you can't have a denominator without a numerator. Since everything canceled in the top, all that's left that is in that numerator is a 1, and you have to have it since it's the top. In the bottom, I'm left with 7x squared. So 1 over 7x squared. All right, number 6. Another multiply. You've got y squared minus 25 over 9y plus 63 times y plus 7 over y minus 5. So again, just like the last one, I'm going to go everywhere I can and do any kind of factoring that I can. So let's see, this top one, look at those two terms and they're both perfect squares. So there's a difference of perfect squares, which means I will have y and y to get the y squared. 5 and 5 is the number that I'm going to use to get to 25. 1 plus and 1 minus. In the denominator, let's see, this is two terms also, but it's a different kind of two terms, right? 63 is not a perfect square. So let's see if there's something in common that I can bring out. What goes into 9 and 63? Well, 9 does. So if I pull that 9 out and divide them both by 9 to see what's left, let's see, if I pull the 9 out of here, all that's left is the y plus 63 over 9 gives me 7. So now let's see, bring down the times. Now, the good thing about this fraction is there's no factoring that you can do here. So you're just left with the y plus 7 over the y minus 5. So let's see now what we can cancel. Let's see, I can do this y minus 5, we'll cancel that one. This y plus 7 will cancel that one. So let's see what is left up top, the y plus 5. And what's left in the bottom, all that's left is this 9. So you have y plus 5 over 9. All right, if you are watching this video, I would like you to send me an email when you get done with this review to tell me that you're watching the videos and that you get 2 bonus points on this Chapter 5 test. So again, send me an email at my Plasky Tech email and tell me you want 2 bonus points on your Chapter 5 test. All right, number 7, y squared minus 81 over y squared minus 8y plus 16 divided by 4y minus 36 over y squared minus 3y minus 4. Okay, now this one's different than the last problems because it's division. The very first step, remember the definition of division is simply to multiply by the reciprocal. So I'm going to rewrite this problem, but I'm going to flip this second fraction and turn this to a multiply. And then I'm going to work it just like the multiply problems. So let's see, I'll just bring down the y squared minus 81, bring down the y squared minus 8y plus 16. Now I'm going to turn this division to multiply and then flip this one. So here the 4y minus 36 will come into the bottom and the y squared minus 3y minus 4 will come up top. Now, remember, before I can multiply and start doing any canceling, I've got factoring all over the place here. So let's see, what kind of factoring is this first one? I have y squared minus 81. So two terms that are both perfect squares. So I'll do y and y for the y squared. Let's see, what's the number that's the same that you can multiply to get 81 using the same number, which will be 9 and 9. One's a plus and one's a minus. In the denominator, this one has 3 terms, but it's just a y squared up front, which is great because that's the easier kind, because the y squared is just y and y. Now, let's see, factors of 16 that add to negative 8. That's one of the things you can put in your calculator. Go to your y equals. And clear it out from our last problem. Put 16 as the number you want to put in. So 16 divided by x. 16 divided by x. And in the second y, 16 divided by x plus x. So it should look like this. And then second table. So what am I looking for in that second y column? I'm looking for negative 8. So once I see that negative 8, that tells me the other 2 numbers in that row are the numbers that I use in my factors. So I'm using that negative 4 times, again, up here, another trinomial with just a y squared, which is good again. So I'll use y and y. I'll put the negative 4 in my calculator. Again, negative 4 divided by x, and then negative 4 divided by x plus x. So negative 4 divided by x, negative 4 divided by x plus x. So again, it should look like that in your y equals. Second table. So this time, what am I looking for? Well, whatever's in the middle, which is that negative 3. So I have it highlighted. So you see the negative 3 in the second y column. So the other numbers in that row are what I'm going to use, which is a positive 1 and a negative 4. So a plus 1 minus 4. Now, in this denominator, again, it's 2 terms like the last one. However, this y right here makes it not a perfect square, right? That's not a perfect square. So the other thing I'm looking for is something in common. So I could actually pull out the 4 from this denominator. So if I pull out a 4 and put in parentheses what is left. So how do I figure out what's left? Well, you take the 4 out of those. So if I took the 4 out of this first term, I'd have a y minus, if I take the 4 out, divide 36 by 4, I get 9. So now everything is in factored form. Now you're going to go through and do all your canceling. So let's see, this y minus 9 will cancel this one. That y minus 4 will cancel that one. And it looks like that's all that's going to cancel. So what you're left with up top is y plus 9 and y plus 1. Let me put this up here on my knee. So y plus 9, y plus 1. over y minus 4, and then this 4 over here. So y minus 4 with the 4. That's what your answer should look like. All right, moving right along. Number 8, find the least common multiple. It says by factoring, but we did it a different way. We have the least common multiple. The numbers are 175 and 245. So remember how we did this in that section. When we were finding the least common multiple, the first thing we did was we went to the biggest number, so 245. First thing we want to do is say, well, does 175 go into 245? So let's try it. 245 divided by 175. So when you put that in your calculator, it gives you a decimal, which just means 145 doesn't go into 245 evenly. So now let's think about this. Now I need to know, what's the next number that 245 goes into? Well, it's whatever 245 times 2 is. That's going to be the very next multiple, or the very next number that 245 goes into. So 245 times 2 gives you 490. So let's see, will that divide by 175? So divide that by 175. So when I divided 490 by 175, it gave me 2.8, which means no, 175 will not go into it. Now, what's the very next number that 245 goes into? Well, it's whatever 245 times 3 is. So let's check that. 245 times 3 is 735. So divide that by 175. So just hit divided by 175, and it gives me 4.2. So I'm still not there. Now let's see. The next number would be whatever 245 times 4 is, which is 980. So let's see, I'm at 980. So let's divide that by 175. And it gives me 5.6. So I'm still not there. Okay, you'll eventually get there. And this way is most of the time faster than the other way. And it's definitely easier. So let's see, 245 times 5 gives me 1225. So let's see. So I'm at 1225. Let's divide that by 175. So when you divided that 1,225, divided it by 75, it gave you 7, which means that 175 also goes into 1,225, which means the very first number that 175 and 245 go into is 1,225. So that's your answer, the 1225. All right, number 9, another least common multiple problem. You've got 45y to the third x squared. And 9y to the 7th x squared. Okay, so again, same thing. First things first, let's do the number part. I've got 45 and 9. 45 is my biggest number. So let's see, 45 divided by 9. So does 9 go into 45 also? Well, since I divided it and you got a whole number, not a decimal, it goes in there also evenly, which means 45 is the first number that 9 and 45 will both go into. All right, now let's see. Dealing with my y's here. I've got y to the third and y to the 7th. Now remember, this simple shortcut. When you're finding the least common multiple with exponents, you just pick whatever the highest exponent for that letter is. So if I've got y to the third and y to the 7th, the highest one would just be y to the 7th. Here I have x squared and another x squared. So the highest exponent is that 2. So 45 y to the 7th x squared. All right, number 10. Got 6a to the third, c to the 8th. 3a to the 6th, c to the 8th. And 14a to the 4th, c to the 6th. So again, I'm finding the least common multiple. So let's see here. Again, same thing. I've got a 6, a 3, and a 14. So who's my biggest number? That 14 is. So let's see. Will 6 go into 14? 6 does not go into 14, and neither does 3. So the next thing I need to do is do what? Find the next number that 14 goes into. So let's see. 14 times 2 gives me 28. So 14 times 2 gives me 28. Let's see, will 28 divide evenly by 6? No, it won't. So it's not 28. What's the next thing 14 goes into? Well, whatever 14 times 3 is. So when you punch that in your calculator, you get 14 times 3 is 42. So let's see, will 42 divide by 6? So 42 divided by 6 goes evenly, so that's a good thing. Well, the other thing I need to do, so 6 is good, 14 is good. Let's make sure that 42 can divide also by that 3. And since it gives me a whole number also, the 3 also goes into 14. I mean, excuse me, not 14, 42, which means 42 is the number part of the least common multiple. Now, look at your A's. Got a to the third, a to the 6th, and a to the 4th. So which one is your highest exponent? That a to the 6th. Then your C's, you've got c to the 8th, c to the 8th, and c to the 6th, which means the highest exponent is c to the 8th. So 42, a to the 6th, c to the 8th. All right, number 11, now we're adding. So you have 2x minus 3y over x plus y plus x plus 8y over x plus y. So when I'm doing this one, first things first, I do have a common denominator, which makes this an easier problem than if you didn't. When you have a common denominator, you're just simply going to turn these two fractions, add them together, and turn them into one fraction over that common denominator of x plus y. So let's see, up top, I'm just going to rewrite this whole thing in the top over that x plus y. So I've got 2x minus 3y plus x plus 8y. And then combine like terms up top. So this 2x, I can put with that 1x. So when I put those together, I get 3x. And then here, I've got a negative 3y and a positive 8y. So what do you get when you put a negative 3 with a positive 8? You get a positive 5y's. And it's still over your common denominator of x plus y. So 3x plus 5y over x plus y. All right, number 12, divide 35a to the 8th minus 10a to the 6th plus 45a to the 4th over 5a to the 4th. Now, remember this section was if you just had one term in your denominator. This is almost like 3 completely separate fractions. So let's think of it like that. And each fraction is over that 5a to the 4th. And then just reduce each of the fractions. So let's rewrite it like that first. So I've got 35a to the 8th over 5a to the 4th minus 10a to the 6th over 5a to the 4th plus 45a to the 4th over 5a to the 4th. So let's see, what I can do here is just now I'm just going to reduce each of those fractions. So here, that 35 over 5, if you want to put that in math, enter, that's fine. That's going to leave you with 7 over 1, a to the 8th over a to the 4th. So if I subtract those exponents, I'm going to be left with a to the 4th, and it's going to be into the top, right? Because I had 8 in the top and 4 in the bottom, which means your leftovers are up top. So 7a to the 4th up top. Now, same thing here. 10 over 5 reduces to 2. If I subtract these exponents, I have a to the 6th over a to the 4th, which leaves me with a to the 2nd. Can you see that? And 45 over 5 leaves me with 9. And here I have a to the 4th over a to the 4th, so those just cancel. So let's see what we have left. This first fraction, all you have left is 7a to the 4th minus the second one, 2a squared, plus this last one, and all you were left with in the last fraction was that 9. So 7a to the 4th minus 2a squared plus 9. Number 13. So this one is a division problem. C squared plus 11c plus 28. Divided by c plus 4. Now, remember when I made that video for you, I showed you how to do that synthetic division. And that's where we made our division symbol like this. But here, this plus 4, we took the opposite of that number and put it out here. So we put a minus 4 out there. Then underneath our division symbol, we just put the coefficients of these terms in here. Okay? So the coefficient just means the number part of. So what's in front of this c squared? There you will just have a 1. What's in front of c? You will have an 11. And then what's your constant? 28. Now remember, this is when we did that all that fancy multiplying where we drew those lines all over the place. The first thing you're going to do is just drop down your 1. Now, the second step is to multiply this negative 4 times 1 and put your answer under the 11. So what's negative 4 times 1? That gives me negative 4. And then add straight down. So I've got 11 minus 4, which gives me 7. And do the same thing again. Negative 4 times 7 and put your answer under the 28. Negative 4 times 7 gives me negative 28. And when I add that straight down, I'm left with just a 0, which is my remainder, which just means I don't have a remainder. So I've got a 1 and a 7 down here. Okay? So since that, well, those are going to be the coefficients of your answer. And remember, your answer starts just 1 exponent less than this. So 1 exponent less than this will just be c to the first power. So I've got 1c to the first power. I don't even need to write it since it's first power. And since that's a positive 7, I'll have plus 7. So c plus 7 would be your answer. All right, number 14, another synthetic division. S to the 3rd minus 9s squared plus 54s minus 19 divided by s minus 6. So I'm going to do the same thing that I did on this last one. I'm going to do the same kind of synthetic division. So let's see, the opposite of -6, which means I'll just put a +6 out there this time. The coefficients, what's in front of s cubed? Well, that's a 1. In front of s squared is a -9. In front of s is a 54. And then my constant is -19. So let's see. Let's drop down my 1. And then do all the fancy multiplying. 6 times 1. And put your answer under that -9. So 6 times 1 is 6. Add this straight down. What's -9 and a +6? Gives me -3. And then start over with your multiplying. 6 times -3. Put your answer under the 54. 6 times -3 is -18. So what's that? 54 minus 18. I'm gonna punch it in my calculator so I don't make a simple mistake on a problem like this. Whoops. Gives me 36. And then the last one, 6 times 36, and put your answer under that -19. So 6 times 36 gives you 216. And then add that straight down. Again, if you want to put that in your calculator, you just do -19 plus 216, which gives you 197. And that's your remainder, is the 197. So let's see, here's what's gonna, these are the coefficients of my answer. Again, start with 1 exponent down from s to the 3rd, which means this is gonna start off with s to the 2nd. Bring down the -3s, and then the plus 36 with a remainder of 197. All right, number 15. Another synthetic division problem. You've got a to the 3rd minus 5a squared plus 8 divided by a minus 2. Now remember, and we saw this in this section, when you are filling in, since that's a -2, we'll put a +2 out here. Now remember, when you're filling in, what's in front of a to the 3rd? A 1. What's in front of a squared? A -5. But what should come after a squared? There's a missing a right here. So for the missing ones, you have to fill in a 0. It's like there is a 0a right there. So that's why I'm filling in that 0 right here. And then after a comes your constant, which is +8. And then start your process. So again, drop down the 1. And then multiply 2 times 1 and put your answer under the -5. So 2 times 1 is 2. Add that straight down. -5 and a +2 is a -3. Then start over. 2 times -3 gives me -6. Add that straight down. 0 and -6 gives me -6. And then 2 times -6 gives me -12. When I add that straight down, 8 and -12 gives me -4. And since that's my last number, that's my remainder. So let's see what is left. 1 exponent down from a to the 3rd means I'll start off with a to the 2nd. Then -3a, since it's -3, and since that's -6, I'll have -6 with a remainder of -4. And this is the one that is multiple choice. So you have a to the 2nd minus 3a minus 6. And remember, your exponent, not your exponent, your remainder goes over this a minus 2. So if you're looking at your paper, it's that C one, right? Because the C is the one that has the -4 as the remainder on top of the a minus 2. All right, number 16. All right, last synthetic division. You've got s to the fourth minus 81 divided by s minus 3. So on this one, again, synthetic division, since that's minus 3, I'll put a plus 3 out here. What's in front of s to the fourth? A 1. What should come after s to the fourth? There should be an s to the third. Since there's not, I'll put a 0 for s to the third. After s to the third, there should be s squared. And since there's not, I'll put another 0. What comes after s squared? There should be an s, and there's not. So that's another 0. And then the minus 81. So again, right in here, there's a bunch of missing terms. There's no s to the thirds, there's no s to the seconds, and there's no s's. So that's why there are 3 zeros down here. And then start your process. Drop down the 1. 3 times 1, and put your answer under that first 0, which is a 3. Add that straight down. 0 and 3 is 3. Do it again. 3 times 3 is 9. So put your answer there. Add that straight down. 0 and 9 is 9. Do it again. 3 times 9. Put your answer there. So that gives me 27. If you add that straight down, the 27, and then your last time, 3 times 27 gives you 81. And when you add that straight down, you get 0. So there is no remainder. So let's see, what is our answer? Here I've got s to the fourth, which means I go down 1 exponent, which means that'll be s to the third. Then, let's see, I got all those arrows. That's a positive 3, so positive 3. What comes after s to the thirds? So those will be s squareds, positive 9, s, and then positive 27. And since there is no remainder, that is your answer. All right, what number are we on? We're on number 17. Now, this is a section that I had that Mr. Rathon had a video for you. So with this one right here, I have 5 plus 2/7 over 5 minus 5/6. I'm going to show you a calculator trick on this because here's the deal. This symbol, this line right here means the top divided by the bottom, right? That's what that means. If you have a fraction bar, that means this up here divided by this. And remember, earlier on in this review, we talked about how division is simply to multiply by the reciprocal. Now, remember, this calculator will add fractions for us. So let's see. The first thing I need to know is what is 5 plus 2/7? So that's exactly what I'm going to tell my calculator. 5 plus 2/7. So it should just look just like that, just like you're on the board. 5 plus 2/7. Hit enter. It's going to give me a crazy decimal, but I don't want the decimal. I want the fraction. So just math enter that. So math enter, and look what it does. It tells me that 5 plus 2/7 is 37/7. So let's see, that's the first part. So this up here is 37/7. Do the same thing in the bottom. So now 5 minus 5/6. So again, it should look just like what your denominator does. 5 minus 5/6. So hit enter, again, crazy decimal. Math enter that crazy decimal. To see that when you do 5 minus 5/6, what does it give you? It gives you 25/6. So now look what we have. We've got 37 over 7 divided by 25 over 6. Now remember, what does division mean? It means to multiply by the reciprocal. So I'm going to leave this top number the same. So 37 over 7. Now, I'm going to change it to multiply. Remember, it means division means to multiply by the reciprocal. So just flip over that second fraction. So 6 over 25. Now, type in this part of the problem. So you just have 37. Actually, let's just go straight, because when you're multiplying fractions, you can go straight across from top and bottom. You don't have to have a common denominator or anything. So let's see, what's up top? You've got 37 times 6. So 37 times 6 looks like it gives you 222 up top. Do the same thing in the bottom. 7 times 25 gives me 175 in the bottom. And then just math enter that to make sure it doesn't reduce. So I have 222 over 175. So put in what you got as your answer in the top and the bottom. Then math enter that. And look what it tells me. It still tells me 222 over 175, which means that is in simplest form. Okay, moving on to number 18. You've got, and it's another simplifying a complex fraction. You've got 1 over x plus 9 over 1 over x minus 7. Okay, so this problem looks harder than it is. So the first thing you're going to do, the thing is, in math, they don't like to have a fraction in the top and the bottom. It just wants it to be more simplified than that. So if you'll notice, the common denominator between these two, the top and the bottom, is that x. So all I need to do is multiply, because this, if I put an x in the top and the bottom and I distribute it, look what's going to happen. This x right here, since you have it, this is in the top. So if I have x in the top and the bottom here, I'm just going to, they'll cancel each other, and I'm just going to be left with that 1. So again, this x, like it went to here, and so then you had x over x, which just leaves you with 1, right? Because anything over itself is 1. Plus, let's see, make the x go to the 9, so 9 times x is 9x. And then do the same thing in the bottom. Make the x come here and here. So if you make x come here and distribute it, you have x over x, which again is just 1. Minus, if I make the x go to the 7, I'll just have 7x. So now I don't have fractions within my fraction. So I just have 1 plus 9x over 1 minus 7x. All right, number 19. Solving. Let's see, I've got 4/5 plus 8 over 27. Equals z over 45. All right, so fractions everywhere, unlike denominators everywhere. So the very first thing I'm going to do is take care of that. I don't want any fractions in my problem. I'm trying to get this z by itself. So let's see, I've got a 5, a 27, and a 45. So remember that section where we were finding the least common multiple, like on this review, number 8, where we found the least common multiple between 175 and 245. That's exactly what I'm going to do here. I'm going to find the least common multiple of all of these denominators. So just like in that problem, I'm going to go to my biggest denominator, which is 45. So does 5 go into 45? Yes, it does. It goes in there evenly, so that's good. But does 27 go into 45? If you divide 45 by 27, it gives you a long decimal. So 45 is not my least common multiple. So now I need to see, okay, what's the next thing 45 goes into, which is 45 times 2, which gives you 90. So let's see, will 5 go into 90? It will. Let's see, does 27 go into 90? So 90 divided by 27, It does not. So I'm still not there. I need to find the next thing that 45 goes into. So 45 times 3 gives me 135. So I know 5 goes into it since it ends in 5. 5 goes into it. Let's see. Will 135 divide by 27? And it does. So that 135 divided by 27 gave me 5. So I know that all 3 of those go into 135, which means the least common multiple is 135. So now, here's what we're going to do with that information. I'm going to use the rule of equations that says I can multiply anything on this side as long as I do it on that side. Well, here's what I'm going to do. I'm going to give everybody a 135 up top. So just giving everybody a 135. After I do that, now what did I do? I made sure that all 3 of those denominators went evenly into 135, right? That's why I'm using it. I'm going to divide by 135. What is 135 divided by 5? 135 divided by 5 gives me 27. So this 27. Okay. So 135 over 5 gives me 27. Now I'm going to multiply what is left. I have a 27 times a 4 left. So 27 times 4 gives me 108. So again, the step was divide the 135 by 5. That gave you the 27. Then multiply what's left. So 27 times 4, what'd I say? Gives me 108. Plus, do it on all 3 of these. So let's see, 135 divided by 27. I'll show you exactly what I'm doing. I'm just doing 135 divided by 27. And what did that give me? It gave me 5. So let's see, this 135 over 27 gave me 5. And then I'll multiply what is left. So I have an 8 and a 5 left, which is 40. Equals, do this side too. So 135 over 45. 135 divided by 45. What does that give you? When you divide 135 by 45, it gives you 3. So 135 over 45 gives you 3. Multiply what is left. So I have a 3 and a z left, which means I have 3z. Now look what you have. You have this equation that is the same thing as this equation without fractions. So I'm just trying to get z by itself. Well, I can put these 2 numbers together, that 108 and 40, since they're on the same side of the equal sign. If I add those together, what does that give me? 148 equals 3z. And getting z by itself, which means I just need to divide both sides by that 3. And let's see, will that divide by 3? 148 divided by 3 gives me a long decimal that doesn't reduce. So that just means z is all that's left here. 148 over 3 is what's left over here. So 148 over 3 is your answer. All right, moving right along. Number 20. X plus 12 over x equals negative 13. Okay, so when I'm doing this one again, first things first is I see that this, again, this was in that section 5.5. I'm multiplying everything in this whole equation by whatever the least common denominator is. Well, I only have one denominator. It's just an x. So that's just going to be it. That's the smallest thing that x will go into. So everybody, just like that last problem where everybody got the 135 since it was the least common multiple, this time everybody's getting an x since it's the least common multiple. Everybody on both sides. So let's see, on this side, I have x times x, because the only one that has a denominator that's going to cancel is this one right here, right? It's the one that has the x in the top and bottom, so it's going to cancel it. Everybody else still has an x in the top, so let's see. Unfortunately here I have x times x, which gives me x squared. All that's left here is the plus 12 equals, here I have a negative 13 times x, which is negative 13x. Now, this is going to take us back to something in chapter 4, because I'm still solving for x, but the thing is, I have an x squared instead of just an x like I did on my last problem. Since I have x squared, that means just like in chapter 4, I'm going to have to use that factoring to solve this. So before I can do that, I have to make sure this negative 13x, I need to move it over to the other side. So I need, because I have to have all my terms together on one side. So I'm going to add the 13x here, and I'm going to also add it here. And you'll notice that I'm putting it in between the x squared and the 12 because I'm going to end up factoring here in a minute. So let's look. On the right side, I have my 0. Over here, I have x squared, then the plus 13x, and then the plus 12. So again, I put the plus 13x in the middle of those because now, look, now I can see that I've got a trinomial that needs to be factored. It's a good kind of trinomial since it's just x squared, so it'll be x and x. Now, you can put the 12 in your calculator and your y equals, right? And if you want me to show you that, I can. Just go to your y equals. 12 divided by x, and then 12 divided by x plus x. So in your y equals, it should look like that. Second table, what am I looking for in that last column? I'm looking for the 13. So looking for 13 in that last column. So you can see it there on that second row, which means I'm going to use plus 1 and plus 12 as my numbers. Now remember, after you get the factors, after you got the factors on these kind of problems, you set them each equal to 0. Like that. And then solve them each for x. So on this first one, I would need to subtract 1 from both sides. So I'll be left with x equals negative 1. And here I'd have to subtract 12 from both sides to get the x by itself. So here I'm left with x equals negative 12. So negative 1 and negative 12 are the two answers that you would have for this problem. All right, 21. 5 over x plus 3 over x equals 4. So again, my least common denominator again here is going to be x. This one's not going to be as bad though, because remember, so I'm looking for the least common denominator, which is that x. So everybody gets an x up top. Now look at the left side. Here I have an x in the top and the bottom, so they just cancel each other, right? So all that's left, if this x cancels that one, all that's left is 5. Plus, same thing here. If this x cancels this one, all that's left is 3. So I just have 5 plus 3 equals, over here, I don't have an x in the bottom to cancel this one, so I just have 4 times x, which just gives me 4x. So look, this time I don't have an x squared. That's why it's not as bad. So here, I just put the 5 and the 3 together since they're on the same side of the equal sign, so that's just 8 equals 4x. And then divide both sides by 4. and see what is left. So the 4's cancel here. There's my x. And 8 over 4 gives me 2. So the answer would be x equals 2, or 2. All right, number 22. Now, this is the part of the video where these kind of problems, you'll look, I have x plus 1 over x equals 5 over 4. Now, this is the part of that section 5.5 where we did that cross multiplying, because we had one fraction on one side equal to one fraction on the other. That's where we could do that fancy cross multiplying, which means it doesn't matter which way you go first. I can do this bottom times that top. So let's see, I have 5x times 5, which just gives me 5x. Now that's going to be equal to, do the other diagonal. That's why it's called cross multiplying. So let's see, on this time I'm going to have what? 4 times that whole thing. So you should probably write it out. 4 times all of this, x plus 1. So now, since I see I put that in that, so I want to make sure the 4 goes to everything up there. So I'm going to distribute that 4. I'll just drop down this 5x equals 4x plus 4 times 1 is 4. And then solve it for x. I've got x's on both sides. So let's get rid of our small x. So I'll subtract 4x from both sides. And let's see what's left. 5x minus 4x is just left with 1x equals, over here, all that's left is 4. Well, good. We're done, because look, we're just down to x equals 4. So 4 is your answer. All right, number 23. 7 over 3x minus 2. Oh, what kind of 2 is that? Equals 4 over 9x. So again, just like in 22, I can cross multiply this, and you can cross multiply if you have one fraction equal to one fraction, not something else like a plus 1 out here or something. That would mess this up. But let's go ahead and cross multiply. Again, it doesn't matter which way you go first. So let's say I go this way. So I have 4 times all of this. So write that 4 times 3x minus 2 equals, do the other diagonal, 7 times 9x. Actually, you can just go ahead and do that multiplication, right? What is, since I don't have so I don't have to distribute, there's only one term times one term. 7 times 9x gives me 63x. And then just solve it for x. So let's see. I'll distribute this 4. 4 times 3x gives me 12x. Minus 4 times 2 is 8. Equals 63x. So let's see, I have x's on both sides again. So I'm going to get rid of my small one again. So I'm going to subtract 12x from both sides. So let's see, on the left, I've got a negative 8 equals, when I subtract that, let's see, 3 minus 2 is 1, 6 minus 1 is 5, so I've got 51x. So if I want x by itself, what do I need to do? Divide by 51. So let's see, the 51s cancel, so there's my x by itself. And look, the other side is just that negative 8 over 51. And if you tried to reduce that negative 8 over 51, you would see that it wouldn't reduce. So you're just left with x equals negative 8 over 51. All right, number 24. Almost done. There's only 25. Now, this is that second part of that 5.5, 5.7 section that I ended up making that Mr. Rathon didn't have the end of it on that video that I put out there. So I did make one. So if you need to go back and look at that, that's what these last two problems are. Let's see, I've got y over w equals c over b. And I'm solving it for y. But remember, I'm not going to worry about what I'm solving it for yet. The first thing I'm going to do is make my equation not have fractions. And the way that you do that is you multiply by the least common multiple. Well, look at my two denominators. One's a w and one's a b. The only thing I know of that w and b go into is wb. Okay? Now, I could also use cross multiplication on this problem, right? Since I have one fraction equal to one fraction, but look what's going to happen. This w is going to cancel that one. This b will cancel that one. So let's see, what are we going to be left with? by equals, what's left here? Since those b's canceled, I'm left with cw. Which is what I would have gotten if I cross-multiplied anyway, right? If I would have cross-multiplied without doing this step, I would have multiplied the c times the w, which would have given me cw. And this cross would have been what? b times y, which is by. So it does the same thing. Now, what am I trying to get by itself? This y, which means this b needs to go away. And since it's hooked on, I will divide by it to get rid of it. So let's see, I've got y equals, this right here is just a fraction I can't redo. So I've got a lowercase c, capital W over a lowercase b. And I do think that Math Lab is case sensitive. I will check that after you take your test to make sure you don't get counted off for it though. So you have y equals CW over b. All right, last one. P equals 707.2 W over m squared, and it wants me to solve for m squared. But again, I'm not going to worry about that yet. Let's see, I can see that m squared here is my only denominator. So let's multiply both sides by m squared. Okay, well look, over here it just cancels it. That's why we did it. So on the right, all you're left with is 707.2 W. And what are you left with on the left side? You've got the m squared times p, which is just m squared p. Now let's see, what did it tell me I was solving for? It said to solve for m squared, which just means it wants this m squared by itself. So since p is hooked on, I will divide by it. So the p's cancel. So I'm left with m squared equals this big crazy fraction over here. So I just have 707.2 W over P, which is your answer. All right, so good luck and email me with any questions that you have.